Hey team, back again. This time I have an NLB set up. This NLB, pretty similar to a bit earlier in the blog, has a single target group with 2 targets in it, and those targets are across 2 AZs. The only difference between this NLB and the NLB that I had set up earlier in the blog is that this NLB has cross-zone load balancing enabled. So let's take a look at how it distributes, or let's first of all take a look at the IPs that it's returning for us. So we can see that we're getting three IPs back from this NLB. Now let's try running some requests to a single IP in this NLB. I'll pick that bottom one. So the first request as its own TCP connection, a single TCP connection, goes to server 1. Second one goes to server 2. A third one it pushes to server 2 again. The fourth one, this IP pushes back to server 1, server 2, server 1, server 1. You can see it's not in any particular order, but it should be around about 50-50. Let's just run 100 requests and see what we get. So that's running 100 requests. We can see server 1, server 1, server 1, server 1, server 1, about 5 server 1s in a row, then server 2, 2, 2, 1, 2, 1, 2, 1, 2. You can see it is meant to be 50-50 over the long term, but let's do a little bit of statistical analysis, just like we did before on 100 requests. So this is 100 separate TCP requests, obviously done in 100 separate curls, but this time we're going to sort and unique count those requests. So we run that. We can see 47:53. Okay, that's the ratio for those 100 requests. Let's try it again. We get 49:51. Try it again. 54:46. 52:48. You can see over the long term it is probably averaging out at about 50-50, except in the short term we do get some variation from that average. 41:59 is pretty far off the average. So let's take a look and see what happens if we push all requests through a single TCP connection. So obviously this is 100 different TCP connections done with 100 curls. Using the same method we used last time with the ALB, let's firstly create a TCP connection to that NLB IP address. And now let's push a HTTP request through that connection. So the same method I used before, I can just put it in as text, and we see we get it pushes that request to server 2. Now I'll push another one through. Yes. Oh, pipe broken. Okay. Let's just bring that pipe back up again. Bring that up. First request goes to server 1. Second request goes to server 1 again. Third request, server 1. Fourth, server 1. Fifth goes to server 1. You can sort of see what's happening here. Every single request, every single HTTP request keeps going through to the same server. Now I can sort of run this as many times as I want, and I keep getting pushed to server 1. So let's terminate that TCP connection. Let's try, just to confirm the point here, let's try pushing 100 HTTP requests through the same TCP connection. So what I will do is I will, just the same method I used with the ALB, I will I'll firstly create the text of 100 requests, and then I will pipe that into this TCP connection. and we'll see what happens. You can see we get server 1, server 1, server 1, server 1 every time, every single request. Server 1, every single one goes to server 1. So I could try this again. I'm just going to make it a bit briefer. I'll just type in grep server 2. So you can see every single one from this new TCP connection goes to server 2. So what I might do is just do a count on all this. Sort unique -c to count. So in the next TCP connection, 100 of those HTTP requests went to server 1, and just so we can see exactly what's going on, I sent another TCP connection, and all those requests went to server 2. So essentially, what we're seeing here is that the NLB is a TCP listener on the front of the NLB, and it will maintain that TCP connection all the way through to the server / the target on the other side. So no matter how many HTTP requests you push through that TCP connection, they will all go to the server that you brought up that original TCP connection to. So the NLB cannot see any of the HTTP requests going through that TCP connection. They're all basically tunneling through the NLB. The NLB has no visibility of it because it only has a TCP listener. So that was quite different to what we saw with the ALB and its HTTP listener, which could in fact distribute HTTP requests between server 1 and server 2. So yeah, I think hopefully you all understand the difference now between the TCP listener on an NLB and an HTTP listener on an ALB. Cool, thanks guys, see you in the next video.